Okay, so we are. I have started the streaming and recording as well. Okay, let me start the session. Okay, one cross check. Did you get the mails of previous session? I mean, mail means recording and notes of the previous session.
No, sir.
Okay, I had shared with the team. They told me they will share. Okay, let me just give me a minute. Let me cross check. Okay, so yeah, I had conveyed the message. Maybe they will share with you soon. Okay, so let me share my screen. I have collection of some questions from week 9 to week 12. So we'll mainly focus on those questions because those questions will cover the concepts of week 9 to week 12. Okay, so
Sir, so week 9 to 12 includes in the qualifier exam.
yes, it
Okay.
will be from 1 to 12 actually.
Okay. All right. Thank you.
Okay, how many lectures video you have seen so far?
From the YouTube channel.
Yeah.
YouTube channel, I probably like last class you thought of like the permutations and combination and all those things I completed.
Okay, so I'm asking the playlist which team has shared with you. Like,
Uh, yes, yes.
yeah.
Around 35, I think.
Can you tell me the topic?
One sec. I'll check in 2 minutes, huh?
No, no problem, no problem. Okay,
Because
let me start.
I've
Okay,
written
fine.
everything in the notes. That's why I have to
Oh,
check.
well, well. Fine, not a problem. Okay, let's see. Let's start the first question. So in week 9, we have started with the random variable, right? If you have seen. So what is the random variable? Any thought? I mean, do you have any idea? Anyone? What is the random variable? Okay, one thing. If you don't have any idea and all, okay, so you can simply tell me. Accordingly, I will be having idea whether you are getting or you already knew about it. There's something like that, or else. Uh, I mean, accordingly, I will take the decision to tell you the topics accordingly. No problem. Okay, so you may have seen like sample space and all, right? So what is the sample space and all? So let me write here on my. So sample space is what? Sample space is nothing but collection of all possible outcomes, right? Yes or no? That is something we have seen. Collection of all possible outcomes. This is called sample space. What is a random experiment? I mean, this is suppose you are going to perform a random experiment and you got some outcome. What is the random variable actually? So sometimes say you are performing a experiment and sometimes you are not interested in all the outcomes, right? All the details of that experiment, right? Suppose, but rather than you are interested in the value of some numerical quantity. What I mean by some numerical quantity? Suppose you are going to roll two dice. Okay, then what will be the sample space? Yeah, tell me what will be the sample space?
6 into 6.
Yeah, that is the number of outcomes. I'm asking what will be the sample space. It will be 1 1,
Okay.
1 2, up to 1 take 1 6, right? Similarly, 2 1 up to 2 6. Well, and similarly 6 1 6 2 up to 6 6. Yes or no? So this is your sample space, right? Uh, are you getting this point?
Yes.
Yeah, this is the
Yeah.
called sample space. But what is the random variable, right? See, I told you, when suppose you are going to perform an experiment, and you are not interested in all the details of the experimental result, but you are interested in the value of some numerical quantity. For example, suppose I'm saying you are interested to know the outcomes when sum of both die is 7. Okay, then this will be something, this you are going to, this will be your random variable. This is something we are treating this as a random variable actually. For example, what if you are interested in sum of the both die 7, then what will the possible outcomes?
Like 1625 like that.
Correct. 1625 like that. So here here you will define your random variable as a sum of both die is 7, right? Then outcome for that will be 1 5 sorry 2 5 5 2 1 6 6 1 3 4 4 3, something like that, right? So we are not interested in actual outcomes, rather than we are interested in a numerical quantity, right? Here you can simply see we are not interested in the actual outcomes. Are you getting my point? Right? So whenever you are not interested in the actual outcome, you are interested in some numerical quantity, right? Let's say sum of both die is 7, or you are interested in, let's say, what will be the sub something, okay, what will be the subtraction of the numbers of both die, or odd number, something like that. So you are interested in some numerical quantity, not in the actual outcomes. Okay, so if you go for the proper definition, right, so random variable is nothing but it's a real valued function which is defined on the sample space. Okay, it's a nothing but it's a real valued function. It will take some real value, right, which is defined on the sample space. This is not sum is 7. If you take sum of both die, let's do like this, it will be great one. Suppose I'm saying I'm defining a random variable, sum of both die is 7. I mean numbers of sum of the numbers on both die is 7. Okay, so it's a real valued function. Okay, which is defined on the sample space. Okay, let me tell you some another example, maybe that will give you clear idea. Suppose I'm saying you are going to uh, toss a coin 3 times. Okay, so this is the random experiment, right? Okay, now what will be the sample space? Tell me.
Uh, head tail.
Yeah, let's do like the head tail, or let's do like this, head, right? All head, correct? Head tail
Head
head,
tail.
sorry, head tail tail,
Okay.
tail
And
head tail. Yeah,
HTH.
TTH, THH, right? HHT, correct? STH, and I think TTT, right? You can see total 8 is there. 1 2 3 4 5 6. Yeah, so this is the sample space. Well, so here, suppose I told you, right, when you are not interested in the sample space of all the, I mean, experimental result, but you are interested in some numerical quantity. For example, I'm going to define X as a, let's say, number of, you can say define X as a, X means I'm just, X means I'm treating this as a random variable. RV means random variable. Suppose I'm defining S as a number of heads minus number of tails. Can I define like this or not? Suppose I'm defining a number of heads minus number of tails. So this is the numerical quantity, right? And this you can say this is the kind of real valued function which is defined on this sample space. So what is the possible values your x will take here if you are going to subtract number of heads minus number of tails? Tell me. It will be, for this case, what it will be? How many heads are there?
3.
3. And how many tails?
3.
3 tails are there.
If
For this
heads
case,
is 3, then tail will be 0.
so it will be 3, right?
Yes.
Then for this case,
1 minus 2.
1 minus 2, that is minus 1. Then for this again case, minus 1, correct? Then for again
Yes.
minus 1 THS, 2 minus 1, that is 1, then 1, then 1, then minus 3, right? Okay. So what is the unique value x is taking here? X is taking minus 3, minus 1, 1 and 3. So this is the something called random variable. So this random variable, you can see, this is this random variable which is taking some value. Okay. So I mean it's taking some value which is defined on your sample space. Is this clear? We are not interested in the actual outcomes, rather than we are interested in some numerical quantity. You can define something like number of heads minus number of tails, number of tails minus number of heads, something like that, or number of heads itself only, something. Okay, is this clear? Something, some sort of idea is okay? Okay, so you can define x, y and whatever. Is this fine? Some idea is okay?
Yes.
The real valued function defined on sample space. Okay, now let's, by using this information, so here you can simply say now okay, as I told you, this is called this, okay, this is something called range of your random variable. So means what are the possible values your random variable is taking. So there is one definition called range of a random variable x is the set of all possible value x can take. Okay, this is one information, means meaning of the range. So suppose there is one scenario, let a random variable y be defined as the number of tosses until first head comes on tossing a coin, then what will the range of y? So which option should be correct? So tell me which option should be correct. Experiment is random variable is defined as a number of tosses until first head comes on tossing a coin. Whether option number A should be correct or option number B should be correct. I mean, what is the possible values your y will take?
1, 2, 3.
Okay,
Anything.
means you means option number C. Okay. Any other thought? Any people?
I think D.
D. Okay. Anyone else? See, option number C is the correct. Why? Because random variable y is defined the number of tosses until first hit comes. See, to get first aid or something like that, you need at least one toss, right? Yes or no? You need at least one toss. See, it may be you toss a coin, you got tail. It may be you toss a coin, then you got head, right? This is the one of the possibility, or it's like that, correct? Something like that, okay? So you will require at least one toss, then second toss, then third toss, something like that. So this will be true. Option number D will be true when we are interested to know the number of heads, right? Yes or no? Number of heads or tail. So that if you're talking about number of heads or tail, then it will be number of head can be 0. Number of tail can be 0, something like that. Okay. So here, if you focus here, it is asking about number of tosses, right? So until the first hit comes, so I need at least one toss, then second toss. At it may at third toss it can be hit may appear. Then at fourth toss, fifth toss, and so on. Okay, is this fine, right? Okay, you can simply say yes, no. Accordingly, I will get the idea whether you are getting or not. Otherwise, I have to assume you are getting everything. Okay, so you can simply tell me whether you are getting yes, no, or something like that. Okay, so yeah, so let's move to the next question. Here it's about a scenario is given to you. A machine measures the length of the synthetic fabrics and associated imperfections in the fabric. So question is, let x be the error in the measurement of length and y be the number of imperfections per 10 meters. So which option should be correct? So here it's mentioned options. So this means one option can be correct or more than one option can be correct. Okay. So tell me whether x is a continuous, discrete, or y is a continuous or discrete. You know what is the discrete? Discrete random variable is nothing but where we are interested in count. We can count and it can take distinct value on real number line, right? Suppose I'm saying discrete random variable is what? So I'm writing DRV. So discrete random variable is a count, right? And it can take distinct value on real number line, right? Let's say this one, this one, this one, and this one. It cannot take any value in between these two value. In between these two value, it will take distinct value only. This is the distinct, this is the distinct, this is the distinct. While in the continuous, I'm writing CRV. Continuous random variable is what we cannot count, right? This is something we have seen already. So this is this we can't count out. I mean this we can't count. It's a measurable. We have to measure, and if you are going to measure, and it can take any value between two interval. Let's suppose if you plot on real line, then it can take any value between these two. If you are taking an interval, so that is the key difference in discrete random variable and continuous random variable. So by using this information, can you tell me which one is the discrete and which one is the continuous?
A and D.
A and
D.
okay. Anybody else?
Yes, same.
Same. Okay. So let's see. So A and D is the correct. So here you can simply say why A is the continuous, because here x is defined as the measurement of length, right? We have to measure, and while y is what? Number of imperfection per 10 meters. So y is something discrete. You have to count, right? It will be it will be like one imperfection in per 10 meters, or two imperfections, or three imperfections, are just something like that. Okay. So A and D is the correct answer. Let's come to the question number third. So question number third is, which of the following is are discrete random variables? So you have to choose which one is the discrete. Okay, tell me what about length of the phone call? Okay, just take a minute and tell me which one option should be correct.
Only A.
A is the correct. What about others? Any thought?
B and D.
B and
D.
okay. Anybody? Okay, so how did you think A should be correct? Any thoughts? B and D is the correct answer. See, length of a phone call is what? It's a continuous, right? Can you count, or it's a measurable, right? And it can take any value, right?
Sorry. Actually, I saw that not call. I saw the phone number.
Okay, okay. No, it's not about phone number. So it will start from 0 minutes and something, right? It can take any value, right? and number of customer visiting every hours in the shop. So it's a countable, right? So it's like let's say 10 customers visiting every hour in the shop, or 20 customers, something like that. What about amount of milk? So it's a continuous, right? So amount of milk is the continuous, because we cannot count the milk. We have to measure the milk. Like for example, 1 liter or 2 liter, something like that. Yes or no? If you come to option number D, it's asking about number of accidents taking place every hour on NH10. So it's we are asking, here we are interested in the count of the accident. While option number is what? Travel time from your home to office. Suppose sometimes it can take 0 to 10 minutes or 0 to 20 minutes, something like that. So it can take any value, right? And we are measuring in minutes. Well, fine. Is this clear, right? Are you getting are you able to see the difference? Yes or no? So next step is probability mass function. Okay. So what is the probability mass function? Let me just give you the brief intro, and I will move to the question. So PMF is called short form of probability, okay, mass function. Okay. So what is the probability mass function actually? See, whenever you will be having some random variable, let's say this is taking x is taking value x1, x2, x3 up to xn. Okay. And so see there, if this is taking some value x1, x2, x3 and xn, so there will be some probability associated with each value or not. So actually what we are doing in probability mass function, we are interested in the probabilistic behavior for each values of x which is taking. Means what is the probability that this my random variable will take value x1? Let's say it's a p1. What is the probability that my random variable x will take value x2? Let's say it's a p2. For x3, suppose this is p3, and so on. For xn is the pn. So there is two, basically, as you can simply say, it's a probabilistic behavior. We are interested in the probabilistic behavior for each values. Okay. There is two key properties for a B to be a valid PMF. Okay. So what is that key property? So first property is all the probabilities. So I'm writing Pi should be greater or equal to 0. Pi means P1, P2 up to Pn. Second one is summation of all the probabilities, right? That means this summation of P1, P2, P3 up to Pn should be equal to 1, because probability cannot exceed 1 and probability can't be 0. That's why first there is two key things which you have to check. First, probability should be greater than or equal to 0, and summation of all the probabilities is equal to 1. Then it's called the valid probability mass function. Okay. For example, here if you see in this example, okay. So what is the probability that it will take 3h? Okay. What is the probability for getting ahead?
1 1.
1 1.
No. One time, only one time.
What is the probability of this triple H? Tell me, what is the probability of getting H?
8p1.
I'm asking about probability. If you're saying 8p1, how can probability can be 8? Just think a little bit. What is the probability? Probability is something favorable case divided by total.
1/8.
1 by 8. Yeah. You can simply see what is the total. Total is 8. Out of 8, I'm asking what is the probability for HHH, right? Or else you can simply say probability of HHH means what? All are independent. I will write probability of H into probability of H into probability of H. I can write or not? Okay. If this is the case, so it will be half into half into half. I will write simply 1 by 8. That is also correct. So here you can see, so what I'm asking, so here in this case, your random variable is taking value -3, right? Yes or no? So when this is taking -3 for this last case. So it will be, here you can simply write x is taking -3, -1, 1 and 3. then what will the probability x equal to x means for each x? For minus 3, it's 1 by 8, right? Yes or no? And x is taking minus 1. So for minus 1, what is what? Okay, for minus 1, these are the three cases, right? Either this can be, either this can be, either this can be. Yes or no? And for each case, what is the probability? 1 by 8, 1 by 8, and 1 by 8, right? Are you getting what I'm trying to say here? Yes or no? Hello, are you getting this point? Anyone?
Yes, sir.
Then what will be? Then what will the probability if x will take minus 1? What should I write here? If this is the unique case, so for minus 1, when x can take minus 1 for all these three cases, right? Yes or no?
Yes, sir.
See,
Yes.
what I'm asking, x will be take minus 1. When x is taking minus 1, when these all three cases, right? STT, TST, and TTH, right? Then that means probability of TT, no, sorry, HST plus probability of, sorry, STT, 1 minus 2. Okay, STT, TTH, HTT, TTH plus probability of TST. Then for all case, it's a 1 by 8 plus 1 by 8 plus 1 by 8, right? So this is 3 by 8. Are you getting my point? When x will take minus 1, right? So here x will, we are interested when x is taking unique value. So for minus 1, it's 1 by 8, right? For 1, you can see again we will be having three case, right? Yes or no? So again it will be 3 by 8. It will be 3 by 8, sorry. And for 3, 1 by 8. So if you see, this is something called probability mass function of your x. So if you see in this case, all the probabilities are greater or equal to 0 or not? Yes or no? If you see the valid
Yes.
PMF, and if you add all the probabilities, then it's a 3 4 by 8, then 7 by 8, then 8 by 8. So if you add all the probabilities, means 1 by 8 plus 3 by 8 plus 3 by 8 plus 1 by 8, which is nothing but 8 by 8, which is equal to 1. So this is something called valid PMF, right? PMF, I mean probability mass function of x. So what is the probability mass function? Means we are interested to know what is the probabilistic behavior for each values of x. Probabilistic behavior means if x is taking minus 3, then what is the probability? Probability is 1 by 8. If x is taking minus 1, then what is the probability for taking minus 1? Probability is 3 by 8, because for minus 1, there is three possibility. Either this one can be there, or this one, or this one. For 1, either this can be there, or this can be there, or this can be there. Yes or no? For 3, only this will be there. For minus 3, only this will be there. So this is something we are doing in discrete case. Actually, probability mass function, this is defined for discrete case, because here it will take distinct value on real number line. Okay, some sort of idea is okay. Is this clear? Fine.
Yes, sir.
Okay, by using this information, here question is a random variable takes the values 1, 2, 3, 4, and 5. This table 8.5, this gives the PMF, probability mass function of probability x equal to x of, then you have to find the probability of x equal to 5, that is probability x equal to 5. Okay, tell me, what is the probability of x equal to 5 here by seeing the table?
3t by 2.
3 by 2. Okay, but we don't know the value of t here, right? Yes, sir. No?
Yes, sir.
We should
Yes, sir.
find the value of t first. But to
Yeah.
find the value of t first, we know two key properties, right? So what are that property? All the probabilities should be greater or equal to 0. And summation of all the probabilities should be equal to 1, right? So this property I can use, right? If I will add all the probabilities and I will equate it to equal to 1, then I will get some value of t, and then find the value of t. Okay, so I'm just giving you some 2 to 3 minutes and solve it and let me know the answer. Okay, so please solve it so that you'll be having some idea how to solve the questions. Did you get it? Anyone? Are you trying, right?
Yes.
Okay, yeah, thanks. Are you able to do this or you are facing difficulty? Okay. Anyone, did you get the answer? Answer is option number C. 3 by 8 you should get. If you are no one.
Sir, it's a quadratic equation. It did not
Okay.
solve
No,
to
no
answer.
problem. No, let me solve. Okay. So is this clear, right? So probability x equal to 5 is 3t by 2. We know, but we don't know the value of t. If you don't know the value of t, then I have to use the property of being a valid PMF, right? So because we have to prove anyhow probability mass function should be valid. So I will use this property. Sum of all the probabilities should be equal to 1. So what is the, it's 0 plus t plus t by 2 plus 4t square plus 3t by 2 equal to 1. Yes or no? So what you will get here, 4t square, let's do like this, and this t by 2, 3t by 2 will become 4t by 2 or not? Plus t equal to 1. Yes or no? Next step will get 4t square, and this will be 2t plus t, then this is 3t and equal to 1. That means I can write 4t square plus 3t minus 1 equal to 0. Yes or no? Now what should I
Yes.
write next? How we can I can simply write 4t square plus 4t minus t minus 1. Yes or no? This is just a quadratic equation we have to solve. So here you can see 4t I can take common. It will be t plus 1 minus 1 I can take common. Then again it will be t plus 1 equal to 0. So we will be having 4t minus 1 and t plus 1 equal to 0. So from here you can simply say t is either minus 1 or 1 by 4. Yes or no? So what should I take? Whether I should take t as a minus 1 or 1 by 4?
We have to apply it and see the result.
Now tell me which value of t should be appropriate?
Okay, 1 by
Minus
4.
1 or 1 by 4?
Yes.
Hello?
1 by 4. It's
Why not minus
simplest
1?
possible.
Is there any reason?
It's negative.
It's a negative, and we know probabilities cannot be negative, should be greater or equal to 0. So we cannot take x as a t as a minus 1, then we have to take t as a 1 by 4. So if you see t as a 1 by 4, then what is the probability of x equal to 5, which is 3t by 2, 1 by 4, that means 3 by 8. So 3 by 8 is the correct answer. Okay. So this is something you have to keep in your mind, the two basic properties of being a probability mass function. So next one is it's given as cumulative distribution function of the number of defective items in the shipment of every 10 items is given as follows. So this is something given as cumulative distribution function. Okay. What is the cumulative distribution? Normally we are denoting with a capital Fx. So what is the cumulative distribution function? Let me define. Let me tell you the idea behind it. So next topic is called cumulative distribution function. Okay. Short form is this called CDF. Okay. So what is the case? If you see here, okay, let's see here. If I ask here in the question, it was probability x equal to 5, right? If I will ask probability x equal to 3, then you can simply tell me t by 2, right? That means 1 by 8. Yes or no? If I will ask probability x equal to 2, you can simply tell me 1 by 8. Sorry, 1 by 4. Yes or no? Right? So this is something in PMF we are aware about the individual probability, right? Probability E x equal to xi is nothing but pi. But what if I'm interested to know the probability till a point? Means, so for example, suppose I'm saying S is taking value 1, 2, 3, and 4. Okay. Let's say for a probability x equal to x is nothing but, let's say 1 by 8, 3 by 8, 3 by 8, and 1 by 8. For example, just assume randomly. Okay. So if I will ask what is the probability x equal to 1, you can simply tell me 1 by 8. Probability x equal to 3, you will simply tell me 3 by 8. Right? What if I will ask what is the probability x less or equal to 3? Then what you have to do? Tell me what is the meaning of probability x less or equal to 3? Can you think a little bit?
We should find till the point of 3.
Correct? Correct. That means we have to add all the probabilities, right? We have to add all the probabilities, right? Less or equal to 3 means what? What is the range of x? We have to start from the initial values of x. So here it means, see, what we are doing, we are accumulating. If you see, we have to accumulate, or we are accumulate, we are accumulating all the probabilities till a point, right? Rather than as individual probability. So this is something, that's why we are saying cumulative distribution function. So normally we are denoting this as a f of x. The small x is taking one of the value, or you can simply say f of a. This is nothing but probability x less or equal to a. So normally we are denoting small x. Small x is taking the value, is the one of the possible value of your random variable. So this is something defined as your random, cumulative distribution function. Okay, if this, okay, let me write, you will tell me the case. Suppose x is defined 1, 2, 3 and 4. How will you define probability x equal to x? So let's say this is 1 by 8, for example this 3 by 8, 3 by 8 and 1 by 8. So what is the f of x? Okay, so f of x, tell me, if I will write x is less than 1, then what should be the probability here? How will you write here? What should I write?
0.
0, right? Because
Yes.
there is no value, this is impossible, right? There is no value less than 1, right? It will be 0. If I will write x is more than, greater or equal to 1 till 2, because I have to consider this, what should I write? So this
1 by
means
8.
what? Before 2, right? So I will write 1 by 8 before 2, that means only 1 by 8. If I will write 2 to 3, then
3 by 8.
just think a little bit. Just go with this case. I'm interested in till 3, right?
0.
1 by 8 plus 3 by 8.
Correct. We have to add this case and this case. We will get 4 by 8, right? And what about 3 before 4? 7 by 8, right? And x is greater or equal to 4, it will be 1. Correct? We have to add all the probabilities, right? So this is something we are denoting the CDF, right? So if you see, okay, suppose I will ask, suppose let me denote the CDF. So this is capital Fx, this is small x. So small x taking, let's say, value 1, 2, 3, 4, for example. Suppose this is some sort 1 by 8. This is 3 by 8 and not 3 by 8, 4 by 8. That means half. Let's say this is 4 by 8, for example, and then this is 7 by 8 and 1. So how we are plotting the CDF plot? So if you see, before 0, it is 0, right? It is taking value 0, right? From 1 to before 2, it is taking value 1 by 8, right? Yes or no? If you see, I'm making a solid blue. If you see, solid shaded region, when equality is there. And from 2 to 8, what is the probability? Sorry, 2 to 3, 4 by 8. Okay. So it will be from 2 to, I'm just trying to explain something. 2 to 3, this is 4 by 8. And from 3 to 4, it is taking 7 by 8. Right? And from 4 onwards, it will take value 1. Right? See, that's why, see, if you see, f of x cannot take value more than 1. So f of x is the function for which range is 0 and 1. Okay, so what is the thing I'm trying to explain here? If I will ask what is the probability x equal to 1, then, so if you simply see, this is the jump, right? Jumps are there, right? Correct? So this is the CDF of something called CDF of discrete random variable. Okay. So whenever you will be having discrete random variable, there will be jump. If you see the CDF of continuous random variable, right? So you will get the graph something like that. Anything. I mean, it can be anything, but it will start from 0 and it will be 1. But there will not be any jump. While in this case, there are jump. Okay. If I will ask what is the probability of x equal to 1, then can you tell me this jump will define the probability of x equal to 1 or not? This jump, right? This will tell me the probability of x equal to 1. If you have given the one is CDF plot, I will ask what is the probability at a single point or individual point. Then what should I write? What will the probability of x equal to 1 here?
1 by 8.
1 by 8, right? Now, what is the probability of x equal to 2? This jump? Yes
3
or
by
no?
8.
Because at 2, this is the jump, right? So, how did you calculate this 3 by 8? 4 by 8 minus 1 by 8, that is 3 by 8. What is this 4 by 8? You can simply see what is this 4 by 8. This is nothing but probability x less or equal to 2 minus probability x less than 2. Only then you can find probability x equal to 2, right? Yes or no? Okay, see, this is a very basic property. Suppose I'm writing probability x equal to 2. I'm writing probability x less or equal to 2 minus probability x less than 2. Only then I can find equality, right? This means what? Probability x equal to 1 plus probability x equal to 2 minus less than 2 means it is taking only one value. So x equal to, this will get cancelled out. I will get probability x equal to 2, right? That's why I have written like this. Okay. Actually, this is the backend algorithm. Okay. So you can simply see we have to the difference, we have to find the jump. For this probability x equal to 3, what will be this jump? This is 3 by 8, right? And for probability x equal to 4, this will be how much?
1 by 8.
1 by 8, right? So this is something called CDF. In CDF of a discrete random array, you can see there is a jump. Okay. Now, by using the same information, this is CDF is given to you. You have to find the probability that there are 3 defective items in the shipment of 10 items. Then what should we do? It's a very straightforward question. You have to find the, okay, how will you write this probability of there are 3 defective items? That means I have to calculate the probability of x equal to 3, right? Then what should I write for this?
Probability x greater than equal to 3, and we will subtract it with less
Basically,
than
can
3.
I subtract with this this and this? I
Yeah,
will get probability x equal to 3 or not, right?
yes.
Right, this is something. Basically, you have to subtract the if you see here, what is the case? I have to subtract from the previous to lowest, right? Correct. See here, if you plot CD, just do a plot. This is x, this is capital Fx, right? X is taking value 0, 1, 2 and 3. Before 0 it is taking value 0. At 0 it will take, let's say 0.41 is here, 0.41 to 1. Okay. From 1 to 2 it is taking 0.78. Suppose this is the 0.78. Well, from 2 to 3 it is taking 0.91. Suppose this is the 0.91 and 1 will be here. Then after 3 onwards it will take value 1. So to know the value probability, we have to find this jump. This jump is what? 1 minus probability of 1 minus 0.91, which will give you 0.09. Is this clear? Right. So CDF is nothing but when we are interested to know the probability, and we have to accumulate the probability, we have to add the probability till a point. Okay. Is this fine, right? If I will ask what is the probability x equal to 2, then tell me. What should I write?
0.91 minus 0.78.
Yes, 0.91 minus 0.78, which is nothing but 0.13. Okay, this is something you can calculate. Well, now so next question is from week 10 actually. So week 10 is about expectation and variance of your random variable. So this is the question. Okay, this is called expectation of uniform distribution. So there is two kind of uniform distribution. Let me give you some intro about them. Then I will move to the question. So there is two kind of uniform distribution. Okay. First is discrete uniform. Since we are discussing discrete, then I will tell you the discrete uniform distribution, and then we'll move to the continuous when I will come to the continuous. So discrete uniform distribution is nothing but x will take value, let's say 1, 2 up to n. Then for each value there is equal probability, and it is taking with uniformity there, right? If for each value of x there is probability, it's equally likely. This is something called discrete uniform. But before that, let me tell you what is the expectation. So expectation is nothing but, so suppose PMF is defined as let's say x is taking value x1, x2 up to xn, and for each xis, okay, there is probability, let's say p1, p2 up to pn. So how we can calculate the expectation of random variable? So we are denoting e of x. This is nothing but we have to add all the probability. I mean, we have to add all. We have to basically do each xi into p1. I mean, basically xi into pi. So what we are doing? We are multiplying xi into pi plus x2 into p2. Basically, this means x1 into p1 plus x2 into p2 plus so on plus xn into pn. So this is something we can calculate the expectation of a random variable. I'm not going to in that depth because we have to cover other thing also. I'm just telling you the via formula. Basically, let me give you some intro about 2 minutes. So expectation of is something called, it's called long run average. Okay, so we are not going depth. So actually, it's a long run average means whenever you are going to perform any experiment, let's say no large number of times. Suppose you are going to roll a die, let's say some 1,000 times or 1,000 times or 10,000, something like that. So what is the long run average? If you will calculate the expectation of x, right? Okay, before okay. If you are going to roll a die, then what is the possible value your x will take? 1, 2, 3, 4, 5, 6, right? Yes or no? And what will the probabilities? Probability will be 1 by 6 for each value. Yes or no? Right?
Yes.
So this is, now you can simply see this x is here discrete uniform, right? For each value it is taking same probability. So what is the expectation of x? How you can calculate? So you can see summation of xi into pi means 1 into 1 by 6 plus 2 into 1 by 6 plus 3 into 1 by 6 plus 4 into 1 by 6 plus 5 into 1 by 6 plus 6 into 1 by 6. So you will get basically 3.5. So what is the meaning of expectation here? Basically, it's a simply means it's called sometimes long run average. So long run average means if you are roll a die, right? If you roll a die, let's say a large number of times, let's say some 1,000 times, something like that, then average of all the outcomes, okay, average of all the outcomes will be close to this expectation of x, this 3.5. Okay, so expectation of x is always helpful whenever you know, suppose you are going to play a game, okay, where let's say you are going to roll a die and bet is something like that. If you will get odd number, you will win 100 rupees. If you will get even number, you will lose 50 rupees or something like that. Then whether you will would you like to play the game or not? Then what you can do, you can simply calculate the expectation value, expectation of that random variable, and you can simply see if it is coming in positive, then you would like to play the game. If it's coming in negative, you would like to play I mean to stop the game, something like that. Okay, so this is the helpful tool whenever you are going to perform the it's called basically large long run average. Okay, this is something we can calculate the expectation of x. See, this will tell you the expectation, this will tell you the expectation of your random variable. What about variability, right? Variability or variance. So variance of your random variable x is defined as nothing but expectation of x minus mu whole square. So this mu is what? Mu is just notation. This is again expectation of your x. So if you see, hopefully you have remember what we were doing while we were calculating the variance of some observations. We were doing 1 upon n summation I to n xi minus x bar square, right? This is something formula we were using, correct? Yes or no? If you can recall from week 3, week 4. So this is the same case. What we are doing, we are going to subtract the mean and then we are going to take the square. Okay. So this is something we can calculate the variance, but there is if you expand this formula, right? This if you see expectation of x square plus mu square minus 2 times of mu and x, then you will get another formula which is simplified, which is notation is expectation of x square minus expectation of x whole square. So this is something we are using most frequently, because if you have random variable, so expectation is given to you, then you can simply calculate the expectation of x square. Okay. So how we can calculate the expectation of x square? For example, let's say x is taking value x1, x2 up to xn. Okay. Then probabilities for each value, let's say p1, p2 up to pn. Then how you can calculate the expectation of x? This is nothing but summation of each xi into pi, right? Then to calculate the expectation of x square, you can simply see what we are doing here. We are squaring the each values. That means we have to do xi square into respective probabilities. That is what we are doing. X1 square into what is the probability for this, plus x2 square into what is the probability for this, same and so on, xn square into what is the probability. So this is something we can calculate expectation of x square. We have calculated expectation of x, and we can simply subtract, and we will get the variance of x. Okay. Now, if you want to calculate the standard deviation of x, we know what is the standard deviation. This is nothing but square root of variance, right? This is something we have seen already in week 3, but that was for separate observations. Here we are talking about in terms of random variable. Okay. Well, so by using this information, it says uh, like expectation of discrete uniform distribution. This is the probability mass function is given in this. It is says expectation is given to me. Okay. Expectation is given as 10. What is the value of n here? So, and we know what is the expectation. Expectation of random variable is defined as a summation of x into px, right? Yes or no? So if you see what is the expectation of x, let's calculate it. If you see, then what I have to do? I have to do 1 into 1 by n. Yes or no? Plus 2 into
Yes, sir.
1 by n, plus 3 into 1 by n, plus so on, plus n into 1 by n. Yes or no? So
Yes,
what I
sir.
can write, 1 by n I can take common. It will be, I will be having 1 plus 2 plus 3 plus so on plus n, right? Now, if you see, what do you know this summation, sum of n natural numbers? It's a n into n plus 1 by 2. This is something you can check. Okay, this is something, this is the expansion of this summation of n natural numbers. So n divided by n. So n will get cancel out. So we got expectation of x here as n plus 1 by 2. And in the question it is given at this is the 10, right? We have to calculate the value of n. So from where it will be n plus 1 equal to, it will be 20. So value of n will be 19. So 19 is the answer. Is this clear?
Yes, sir.
Okay. Yeah.
Yes.
So let's come to the next things. So can you tell me which option should be true here? This is the linearity property on expectation. If some of you have seen the lecture video,
B and D.
B and D. Okay, why not option number A? Option number A is also correct. Okay. So why? Because okay, there is some linearity property. You can simply check. So what is okay? Tell me what will be expectation of a constant? Let's say expectation of 2.
2 into summation of PX. Summation over PX.
Okay, see, suppose I'm saying what is the, suppose x1 is take some value, then how we are defining expectation of x? Summation of x into px. So one concept called what is the expectation of a constant value? That means what? If x is taking, let's say x is taking only one value, let's say 2. If x is taking only one value, then what will the probability? Probability will be 1, right? Yes or no? Suppose I'm saying x is a random variable which is taking only one value, then probability for taking that value will be 1 or not, right?
Yes, sir.
So what will the expectation of 2 here? That means 2 into probability is 1, then it's a 2 itself. So that's why we are saying expectation of constant is that constant itself. Okay. So if you see here, first is expectation of ax plus b. So due to linearity property, I can simply write expectation of ax plus expectation of b. And here, if you see simply, so a will be outside, so I can take expectation a times of. I mean, it's not out. It's not about outside. uh, if you solve this, right, you will get the this is the same as this one. Because why I'm like saying like this, okay, you can simply see x, for this example, x is taking 1 2 3 4 and 5. Okay, and then for each probability was 1 by 6, 1 by 6 and 1 by 6, 1 by 6, 1 by 6 and 1 by 6. We got expectation of x as a 3.5. If I will ask probability of 2 times of x, expectation of, not probability, expectation of 2 times of x. So to find the 2 times of x, what will, okay. So what should I do first? I have to calculate. See, here you can see it's not about only x, it's about 2 times of x. If you do 2 times of x, then what will the x values of x here? Values of random variable, it will be 2, 4, 6, 8, 10 and 12 or not. And for each value, probability will be the same. Okay. Then what will the expectation of 2x here? It will be 1 by 6 will be outside. So simply it will be 2 plus 4 plus 6 plus 8 plus 10 plus 12. If you add all this, so it will be 2 plus 4, which is 6, 6 plus 12. 12 by 20, 20, 30, 42 divided by 6, right? Yes or no? So 42 divided by 6, this is 7. So if you see what is this 7? 7 is nothing but 2 times of 3.5. It's nothing but 2 times of expectation of x or not. Correct? So this is something we can check. We can derive. Okay. Is this clear, right? Are you getting? Only effect of on the x values will be there, not on the probabilities. Fine. Are you getting this idea? Yes or no? Are you getting this one?
Yes, sir.
Yes, sir.
Same for if you see this for expectation of ax plus b whole square, then what I can write? I can just apply the for extension of a plus b whole square. Then it will be a square x square plus b square plus 2 times of ax b, right? Correct. So if you see, I can write expectation of a square x square plus expectation of b square plus expectation of 2axb, right? So the a square is the constant, then it will be same as a square times expectation of x square, and we know expectation of a constant will be again constant plus 2ab is the constant, it will be expectation of x. So b and d is correct, not c is correct, because if you expand this, it should be minus 2ab. Okay, this is something linearity of expectation. You can cross check. Now so this is the next question. So I would like to I mean just take some 2 to 3 minutes and try to solve this question. If you're able to solve this question number 8, you will get the idea about variance of your x, including the properties. Okay, before that, let me tell you some properties for variance. Okay, so variance actually of x is defined as expectation of x square minus expectation of x whole square, and this is the expansion of expectation of x minus mu whole square actually. So what about variance of a constant? Anyone can tell me? Can you recall from the week 3 or week 4, if you are going to add a constant, then whether variance will be affected or not? No, right? So variance of a constant is 0 actually. You can simply see here. You can simply cross check from here. If it's variance of a constant, then it will be x will take that constant value, right? And we know expectation of a constant, this is same as again it will be c, then it will be 0 itself. Is this all right? because mu is nothing but expectation of x. Okay, so this is the simplest form of the formula. If you will expand this, you will get this one. Okay, what about variance of any constant into that random variable? Okay, if you'll put here, so I will write expectation of ax, I will write a square x square, yes or no, in this formula,
But
minus
A,
a expectation of ax whole square, right? So if you see, I can take a square by the expectation property. If you apply from here, I can take a as a common, then it will be expectation of x whole square. Now it will be a square expectation of x square minus a square again expectation of x whole square, right? So a square will be outside, then I will be having expectation of x square minus expectation of x whole square. And what is this now? This is variance of x. Okay, so variance of any constant into x, this is nothing but a square into variance of that random variable. If you if I will write variance of ax plus b, then it will be again a square variance of x. It cannot be variance of b because variance of a constant is 0. Okay, so this is something you can apply. And what about standard deviation of x, ax here? It will be standard deviation of, I mean it will be square root of this part. It will be square root of a square variance of x, then it will be a square root of variance of x, which is nothing but a into standard deviation of it, right? You can simply recall, right? If I want to multiply by a constant, then new variance will be a square of that constant into old variance, something like that. Yes or no? Right? So by using this information, this and all, can you tell me? Just take a 2 to 3 minutes and do let me know what should be the answer for this question. Just try, and even if it's wrong, that's fine. I just like you'll get an idea how to approach these kind of questions. Are you able to do it or not? Okay, let me. Yes, no, any thought, or should I start? Should I do?
Yes, sir. You
Okay.
can.
Okay, no problem. Okay, so what is the given? You can simply say variance of number of tickets sold in a day in an opera theater is 25. That means this is my x, right? If you see x is what? Number of tickets sold in a day in an opera theater is 25. That means variance of x, right? So variance of x is 25. Yes or no? Can I write this one from the question?
Yes, sir.
Okay. It says for each ticket sold, the profit is 25 rupees. Okay. Tell me if, let's say, if one ticket has been sold, then for one ticket, what is the profit? 25. Just assume if two ticket has been sold, then what will be the profit?
50. 50.
50. If three ticket has been sold, then 75. Yes or no?
Yes, yes.
If X number of tickets has been sold, then what will the profit? See, 50 is what? 2 into 25, right? 75 is what? 3 into 25. Then for X, 25 times of X or not?
Yes, sir.
Right? So we have to find the variance of 25 times of X. Well, and we know variance of A, X is nothing but A square variance of X. Right? So it will be 25 square into variance of X. So 25 square is what? 625 into what is the variance of X? Variance of X is given to us 25. If you multiply 625 into 25, you will get 15,624. Is this fine?
Yes.
Well, okay. Yeah, then this is the question about, okay, I will tell you one more property actually. So suppose I have two random variable x and y, right? Then if I want to find the expectation of x plus y, then I can simply write expectation of x plus expectation of y, irrespective of whether x and y are independent or not, whether it's given or not. Okay. But you can write variance of x plus y same as variance of x plus variance of y only when if x and y are independent. Only in that case you can write this case. While in the expectation, it doesn't matter whether x and y are independent or not. We can do the derivation, but we are not going to the derivation. You can simply do and cross check. But you can simply see whenever x and y are independent, only then I can say this is the case. Why this is happening? Because variance of x plus y is defined as variance of x plus variance of y plus 2 times covariance of x comma y. So if I will say if x and y are independent, right? So if x and y are independent, that means what? I can say simply covariance is 0, right? So if covariance 0, only then I can write this case. Okay, just keep in this these things in your mind. So by using this, if you see in this question, among the random variable x, y, and z, three random variable, there is one something given relationship y is 2x. We have information x and z are independent, not about y, because y is dependent on x. Okay, because there is a relationship with x, it's 2 times of x. We have information only x and z are independent. If variance of x is 2, variance of z is 7, then what is the value of standard deviation of x plus y plus z? So it's good to start. We can simply find the variance of x plus y plus z, and then I can take the square root of this, and this will be same as the standard deviation of x plus y plus z. So if you see here, first find the variance of x plus y plus z, and in the question it is given that the variance, y is same as 2 times of x. So I can write x plus 2x plus z. So it will be same as variance of 3x plus z. Now I told you in the given question it is given that x and z are independent. So I told you if x and z are independent, right? If x and y are independent, I told you x and y are independent. I can write variance of x plus variance of y. Okay. If this is the case, I can write variance of
3x plus variance of z. Yes or no? And then you can use one of them. Let me write here itself. That will give you question number 9. Okay. So you have to find the standard deviation of x plus y plus z. I can simply take the square root of variance of x plus y plus z. So let's find this variance first. So variance of x plus y plus z. So and y is given as 2 times of x. I can simply write variance of x plus 2x plus z. So it will be variance of 3x plus z. And since it is mentioned in the question, x and z are independent, right? So since x and z are independent, so simply I can write variance of 3x plus variance of z, right? Okay. And we know variance of, variance of a constant into random variable. This is a square variance of that, square of that constant into variance of that random variable. So here I can write 3 square, that means 9 into variance of x plus variance of z. So you can simply see what is the variance of x? 2. Variance of z is 7, right? So 2 and 7 is given to us. So it will be 9 into 2 plus 7, which is nothing but 18 plus 7, which is nothing but 25. This is the variance. This is the variance of x plus y plus z. This is 25. Then what will be the standard deviation? We have to take the square root of this 25, which is the 5. So you can see 5 is the answer here, right? Is this clear?
Yes.
Okay. Yeah, fine. So next question is, suppose an urn contains marble of 2 different colors, red and yellow. A marble is drawn randomly from the urn and its colors has been recorded. Then the marble is kept in the urn back and remixed before the next draw. I mean, suppose you have drawn one marble and then you noted down the color, and then you can you again it's called simply you can say with replacement. You are putting back again in the urn, and then you are going for the next draw. Okay. So it says, suppose the proportion of yellow and red marble in the urn is pi 1 and pi 2. This is just a notation. So proportion for yellow is pi 1 and proportion for red is pi 2. So let the urn has 15 marbles, out of which 6 are red, and total of 10 marbles in drawn from the urn in the stated manner. Means we have to do the with replacement. So you have to find the value of pi 1 and pi 2. Basically, there are total 15 marbles. Okay. 15. Out of 15, 6 are red. Okay. And then the remaining 9 will be yellow. Okay. So you have to find the value of pi 1. Pi 1 is what? It's a proportion of yellow. And pi 2 is what? Proportion of red. Tell me which option should be correct. How will you find the proportion here? Or you can simply say probability for being yellow marble. What is the proportion of yellow? Total is 15. 9 is yellow and 6 are red.
9 by 15.
9 by 15, right? That means 0.6. Yes or no? And
Okay.
6 by 15, that means 0.4. So option B will be correct or not? That's all. Okay.
All the other information is only for confusion.
It's not about confusion. Question number 11 is based on that.
Okay.
Okay. So question number 11 says, in the experiment, find the standard deviation of number of yellow balls drawn. Actually, let me, okay, before going to that, let me give you, okay, all of you have seen that's binomial distribution. Yes or no? Uh, Let me tell you something. Before binomial, there is called Bernoulli trial or Bernoulli experiment, right? So what is in Bernoulli? What's the case? I will give you just some rough idea. Actually, in Bernoulli trial, whatever the experiment you are performing, right? For each trial, there will be only two possibility, which is called success, right, or failure. Okay. Success and failure means normally we are denoting success as 1, failure with 0. And there will be some probability for success, let's say P. And since there is only two possibility, then for failure it will be 1 minus P. Let me tell you take one example. Suppose I am going to toss a coin. Okay. If you are going to toss a coin, then there will be only two possibility, right? Either head or tail. Yes or no? So suppose you are interested in head, then this getting a head will be your success. Then it will take value 1 and tail will take value 0. Say suppose coin is unbiased or fair coin, then for each probability will be 1 by 2, 1 by 2. Okay. So normally generally what we are doing is, suppose x is the Bernoulli random variable, then it will take value either 1 or 0. If it will take value 1 with the probability P, it will take value 0 with the probability 1 minus P. Okay. So this P here in the case of coin tossing, it will be half and it will be half. Okay. Because x can take only head or tail. It can be anything, like let's say suppose you want to know the exam result, whether a student will pass or fail, something like that. Okay. Now so this is the Bernoulli. So what is the binomial distribution actually? Okay. So what happens is binomial distribution. Suppose you want to, it's a basically sum of an IID Bernoulli random variable. Okay. So what is the IID means? Independent. It's called independently and identically distributed, right? So all the random variables should be independent and identical. It's basically sum of an IID Bernoulli random variables. So what I mean by this sum of n IID means, suppose you are, okay, let's take the coin toss example itself. So suppose you are going to toss the coin, let's say here in this Bernoulli trial you are tossing the coin one time. Suppose you are going to toss the coin 10 times. Okay. And you have defined your x as a number of heads. Okay. So here what is your success? To get a head, right? So what will the success probability? P as a half. Okay. So if you see here, okay, let me tell you one PMF form for Bernoulli. So for Bernoulli, it's nothing but PMF form is P raised power x 1 minus P raised power 1 minus x. Okay, this is the PMF form. Probability mass function for your Bernoulli random variable. Okay, you can simply check like if you put here. If you put here 1, right? If you put here 1, that means you will get P only, right? Because 1 minus 1 will be 0 and 1 minus P raised power 0 is 1. If you put 0, you will get 1 minus P, right? So there is only two possibility. So what happens here in a binomial distribution? Suppose you are interested in the number of heads. Suppose, for example, suppose you got out of 10 trials, suppose you are going to toss the coin 10 times. Out of 10 times, suppose you got 6 time head. Okay. If you got 6 time head, that means you got 4 times tail. Yes or no? So what is the probability to get the 6 times head? Let's talk about in P itself. That means P into P into P into P into P into P. And for tail is we are considering as a failure, then it will be 1 minus P, 1 minus P, 1 minus P and 1 minus P, right? So what is happening here? P raised power 6 into 1 minus P raised power 4. Yes or no? Since we got 6 times head out of 10, then I will write 10 choose 6. Okay. So this is something form of probability mass function of binomial random variable. In general, here it will be probability x equal to 6. So in general, probability that x equal to x, we are writing x follows binomial distribution with there is 2 parameter and number of trials and p. So this p of x equal to x will be n choose x. Okay, p raised power x 1 minus p raised power n minus x. Okay, is this clear? How this formula came? Okay, so expectation of x is if you solve this summation of x into px, we are not going into the derivation part. So expectation of this binomial random variable is n into p. Okay, you can keep in mind, no need to go in the derivation. If you want to, you can simply do, you will get. And variance of x is nothing but np into 1 minus p. Okay. Is this some sort of idea is clear to all of you? Or do you have any doubt?
So can you explain with the example?
Yeah, I will come to that. Okay, is this this tossing coin is okay? How we are writing this one? Because suppose you are going to toss the coin 10 times, right? So all are independent. You can simply see, right? If you toss the coin 1 times, either you can get head or tail, right? Yes or no? Suppose
Yes.
see, why I have written sum of NID Bernoulli. Let's say here 10. I'm see. If you toss the coin 1 time, right? Then either you will get head or tail, right? See, this is 1 time. Either you will get head or tail. If you toss second time,
Yes.
either you will get head or tail. If you got toss third time, either you will get head or tail. Similarly, if you toss 10 time, either you will get head or either you will get tail, right? Yes or no? So if you see what we are doing, we are going, if you see the individual case, right? Then it will be Bernoulli. If you conclude all 10 as a together, that means what we are doing, summation of each xi. Actually, here this come whenever we are doing summation of each xi, right? Let's say x I is equal to 1 to n. This become binomial n comma p. Each xi is nothing but Bernoulli with p. Okay. So I will take that example actually. So here you can see all are independent. Means suppose you toss a coin first time, then you got something, let's say head or tail. If you are going to toss the coin second time, so whether result of the first toss or second toss will depend on the first toss. Will it be depend or not?
No.
No, right? Similarly for third, right? Outcome of the third toss will depend on the second or first. No, right? So all are independent. That's why we are considering independent and all. Okay. Actually, here you can see, right? If you see here, in case of Bernoulli itself, so expectation of x is what? We are doing summation of x into px, right? So it will be 1 into p plus 0 into 1 minus p, right? 1 into corresponding probability, 0 into corresponding. So expectation of x is p, correct? Similarly, if you solve this variance of x, you will get p into 1 minus p. Here x is Bernoulli. So in binomial, what we are doing, we are checking the NIID Bernoulli, sum of NID. So that's why for binomial, it's NP and Bernoulli, sorry, variance NP into 1 minus P. Okay, this is something formula you can keep in your mind. Okay, okay. First of all, before this formula, is this concept is okay to all of you? How did we get this? Right? Suppose you are going to toss a coin 10 times, you got hit 6 times, that means you got p into p into p into p. This p can be anything, right? It can be half if you have a fair coin or unbiased coin. If there is something else, then we'll see. I mean, accordingly, okay, let's talk in general. So it will be, you are getting success 6 times, right? I will write p raised to power 6. Then failure 1 minus p raised to power 4. In how many ways you can get 6 success out of 10? It can be out of 10 choose 6. Yes or no? So actually this formula came from this concept. So this is in general. Means small x is the, you can say, one of the values. So you will get small x number of success out of n. So here your x will take value 0, 1, 2 up to n. Means you can get 0 success. Means if you talk about coin toss, you can get 0 head, 1 head, 2 head, up to 10 head or whatever. So it's something like that. So success is one more thing. Success is not about head always. It can be tail also, right? But it will be depend on your objective of the question. Now let's come to this question. It is asking, in this experiment, find the standard deviation of number of yellow balls drawn. Okay, how many balls they are drawing? 10. Okay, now let's try to understand with the binomial part actually. So there is total 6 red, right, and 9 yellow, and we got pi 1 as a, means you can say this is the probability or proportion of yellow as how much? 0.6, right? Pi 2 was proportion of red was 0.4. Now, since we are doing the with replacement part, so this probability will not get changed, right? See, okay, what I mean by probability will not get changed, let me explain. Let me explain here. Suppose here you have 6 red and 9 yellow. Okay, if you draw okay, if you are going to draw one ball, okay, let me tell you. Tell me, if you draw one red, then what will be the probability here? Total is 15. What will be the probability?
6 by 15.
And if you draw one yellow, then
9 by 15.
suppose I'm doing without replacement, right? If I'm not going to putting back the again the ball which I have drawn already in the box, then what will the remaining ball here? 5 red and 9 yellow. If you draw one red, in this case, if you drawn one yellow, then you will be having 6 red and 8 yellow. Would you agree with me here?
Yes, sir.
In this case, if you're going to draw again ball, then suppose you have drawn red ball. What is the probability for drawing a red ball here?
4 red ball.
Not 4.
No, sorry.
5 by 14. Yes or no?
Yes.
If you're drawing, suppose yellow, then it will be 9 by 14. Okay.
Yes.
In this case, if you're going to draw red, it will be 6 by 14 and yellow 8 by 14. Similarly, there will be some remaining. Okay, if you will do with replacement, right? 6 red and suppose you are doing with replacement, means you are putting back again the balls. With replacement, you have drawn one red, one yellow. Okay, let me use the another color itself here itself. Okay. Suppose you are going to do with replacement, so what will be the probability here? 6 by 15 and 9 by 15 again, right? Yes or no? If you are doing with replacement, then I mean you have noted down the color and you are again putting back the ball in the box. You will be having again 6 red and 9 yellow. Yes or no? Same here.
Yes.
Yes.
6 red and 9 yellow. Tell me, probability will get changed? No, right?
No.
So that's why binomial we are using in this case. If you see in the binomial, what is the, okay, it's a Bernoulli, right? It seems for each trial. So if you see here, they are going to draw 10 balls, right? If you draw one ball, for example, since probability will not change, right? So probability is same for each trial. This is the condition for binomial. Here you can see probability is same for each trial, right? It is not going to be changed. So in such kind of scenario, I can use the binomial. Here, if you see, if you draw the first ball, for example, one ball, then this can be either red or this can be either yellow, right? And probability for each case is same, right? Yes or no? Is it changed? See, for pi 1, it will be 0.6, and for yellow, it's sorry, for red, it's 0.4. If you draw the second ball, either this can be red or this can be yellow, right? Again, since we are doing with replacement, if you see in the question itself, it is mentioned we are kept in the urn and remixed, right? So we are doing the with replacement. Again, probability will not get changed. Yes or no? Same if you'll draw all the 10 balls, right? Then it can be red, it can be yellow. It's a 0.4, it's a 0.6. Is this clear so far? So it is asking standard deviation of, if you see in the question, it is asking standard deviation of number of yellow balls drawn. So we are interested in the standard deviation number of yellow balls. So how I can define X as a, if you see in the previous question, I defined X as the number of heads, right? Out of 10 toss actually. So here, what is my X? What is my success? Actually, success means what is the objective? So I'm interested in the number of yellow balls drawn, right? Yes or no? So if I want to apply the probability X equal to X here, and by the binomial formula, it's n choose X, right? P raised power X, 1 minus P raised power n minus X, right? Yes or no? So what will the probability for X equal to, let's say, here we are drawing how many balls? 10 balls, right? So you know X can take any value 0, 1, 2 up to 10. So what is the probability if I'm asking X will take 6 value, or let's say 6 value? Tell me, what should I write? It will be 10 choose 6, right? What is the success probability here? What is the success?
6. P to the power 6. I'm sorry.
Sorry, 6 by? No. What is your success here? Success here, you are interested in the
Yellow.
yellow balls, right? What is the probability for yellow balls? 0.6, right? So it will be
Yes.
0.6 raised power 6. Then 1 minus 0.6 raised power 10 minus 6. This is something probability you can calculate. Okay. Suppose I ask what is the probability X equal to 4 or X less or equal to 4, something like that. Okay. And we know what is the expectation of X. It's a n into P. So what is the n here? 10 into 0.6, which is nothing but 6, right? So variance of X is, we know for the binomial distribution is NP into 1 minus P. Okay. So this is the variance of X is defined. So what is the N here? 10. What is the P here? 0.6. What is the 1 minus P here? 0.4. So if you solve this, can you solve anyone? I mean 10 into, let me do it, 10 into 0.6 into 0.4. So this is, yeah, so directly 24, I mean not 24, 2.4. You have to take the, chuki in the question it is mentioned, we have to calculate the standard deviation of this. So standard deviation of 2.4, standard deviation of X, that means square root of variance of X, square root of 2.4 is nothing but 1.549 something only there. Okay, you can see this is the answer. Actually, you have to keep in your mind the formula of binomial random variable. I mean PMF formula, expectation formula, and variance formula. Okay, the only thing is you have to identify whether this is a binomial or not. So the key things to identify the binomial, let me clarify. So it's a summation of n independent Bernoulli trial. Okay, and Bernoulli trial means there for each trial there will be either success, either failure. It can be you are interested in number of tails, number of heads, or number of hair. You can see we are interested in yellow balls. Suppose you are interested to know the result of a student, then it can be pass or fail, something like that. Okay, but all trials should be independent and all. And it's here it include the with replacement case, right? Due to with replacement, Actually, why I'm mentioning this? Because for each trial, right? One more thing you have to keep in your mind. For each trial, success probability will be same. Okay, for each trial, success probability will be same when we are doing the with replacement case. So it's a you can say it's a implies this and this, something like that. Okay, so here you can see in the previous question, for each trial, right, success probability is 0 0.6, 0 0.4 point. So success is here, I'm interested in yellow, so it will be 0 0.6, 0 0.6, 0 0.6, right? As you can see from this tree diagram, right? If you are doing with replacement, then again you will be 6 red, 4 yellow, right? Sorry, 9 yellow. Again you will be having 6 by 15, right? That means point. Sorry, I mean for red it will be 6 by 15. For yellow it will be 9 by 15, which is 0 0.6, right? Again here it will be 9 by 15, which is 0 0.6. So you can see success probability is not changing because we are doing the with replacement. And for each trial, since we are doing 10, we are drawing 10 balls for each draw, we have only two possibility. Either that ball can be red or that ball can be yellow. Okay, is this fine? Are you getting some sort of idea?
Yes, sir.
Okay, let's move to the next question. Here it is asking, in a software office, there are 20 junior developers, of which 8 are men, 12 are women. If 5 juniors are to be promoted to senior level, what is the expected number of women in the promoted developers? Okay, before going to this, I will tell you, I will proceed with this example itself. 20 junior developers, of which 8 are men and 12 are women. Okay. Okay, let me take this example itself, ball one. Okay, so as I took the ball, there were total 15 balls, right? Out of which 6 were red and 9 were yellow, right? If you draw one drawn, right, if you I mean if you take one if you draw one ball, it can be red. If this is that, what is the probability? 6 by 15, right? If this is yellow, what is the probability? 9 by 15. Okay, so if you take one red, so what is the remaining? Remaining ball will be 5 red and 9 yellow, right? And here, tell me, 6 red and 8 yellow. Okay. So if you see, what is the probability for drawing a red ball? 5 by 14. For Y, it's a 9 by 14. Again, it will be some 4 red and 9 yellow. And here in this case, 5 red and 8 yellow, right? Again, here in this case, you can draw a red. So for red, it will be 6 by 14. And for yellow, it will be 8 by 14. Again, there will be changing, right? So if you see in the binomial, what was the case? Success probability was same because we were doing the with replacement, right? Here, if you see, the probability is going to change, right? For each trial, right? So why? Because we are doing the without replacement. Okay. So this is the case, right? If your success probability is going to change for each trial, so that is in that scenario, your binomial experiment fail actually. So in that case, our something called hypergeometric comes into the picture. It's called hypergeometric distribution. Okay. In hypergeometric distribution, this is the scenario. Means for each trial, your probability will get changed. So what is the case? Let me create one scenario. I will tell you hypergeometric distribution fails because we are doing the without replacement, due to which success probability will get changed. So this is the case. What is the scenario? Suppose there are total n. Okay, there are, let's say let's talk about, there were total 15 balls, out of which 6 were red, right? 9 were yellow. Suppose I'm saying I'm going to draw a sample of 5 balls without replacement randomly. Okay, if I'm going to do without replacement, then success probability will get changed. And suppose I'm defining x as a, let's say, number of yellow balls drawn in the selected sample. Okay, so far this is clear. Tell me what is the probability that X will take, let's say 4. Tell me what will the probability, what will be the total case? What will be the total case here? What is the total number of way in which you can draw 5 balls without replacement out of 15? In how many ways you can do?
15C5.
15C5. Very good. And what about, what is your favorable case? I have defined X as a 4. That means I have to draw 4 red balls. Sorry, 4 yellow balls, right? In how many ways I can do? 9 choose 4. Because I have total 9 yellow balls, right? And since we are drawing 5 balls, then 1 balls will be out of 6, right? Yes or no? Is this rough idea is clear?
Yes.
Okay, so this is something called, this is called the PMF of hypergeometric. So what we are doing, let me write here in general how we are defining. Suppose there are something n, I'm talking about, let's say in balls, out of capital N, let's say m, small m are yellow, for example, small m we are defining for success, and then capital N minus small m will be red. Suppose you are going to draw small n balls, you are going to take samples without replacement, right? With the same scenario, you can see. And let's say X is defined as a number of yellow balls drawn in the selected sample. Okay. Then what is the probability that X equal to X, means X will take, or X equal to I? Then what is that means I number of balls, right? Or let's say K number, or let's say I itself, I'm going to. So in how many ways you can draw I balls? Sorry, what is the total number of case you are doing? N. So it will be N, capital N, choose small n, right? For the numerator, I'm going to draw I yellow ball. That means it will be MC I, right? And remaining n minus I will be out of yellow. So this is something your define as a, it will be something we are saying it's a minimum of something, minimum of this m and n, because it can be greater or something like that. So you can clarify from the lecture itself. So this is something form of hypergeometric distribution. And what is the expectation of this hypergeometric distribution? It's nothing but small m into small n divided by capital N. So this small m is what? It's nothing but the number of this yellow ball, and small n is the sample, and capital N. So you can simply see here, okay, you can simply treat, in the case of binomial, what was the mean was expectation of X was n into p, right? You can simply see n was the number of trials there, p is nothing but proportion of that case. Yes or no? Are you able to recall? This m by n is nothing but proportion. What is the proportion of yellow ball is? 9 by 15, right? So this is small m divided by capital N. So this is same as hypergeometric when n is very large. We are not going to that part, but I'm just trying to give you some sort of idea. Okay. So by using this information, you can simply see here, this is something hypergeometric, right? Hypergeometric case. Because in this case, you can't, right? You can't do with replacement for person, right? So this is total, there are total 20 people, out of which, out of 20, 8 are men, right? And 12 are women. So you can define your small, how many, what is the sample? This is 5 people are going to be promoted to the senior level. What is the expected number? So first of, this is the hypergeometric case. Okay. So expectation of the, so here this will be your small m, and this is your small n. Small m I have defined because you can see we are interested in the number of women. So this is your success. So whatever your success is there, you can take as a m, and this is your capital N. So expectation of X is nothing but m into small n divided by capital N, which is nothing but 12 into 5 divided by 20. So 60 by 20, which is nothing but 3. Okay. So this idea behind this hypergeometric is clear to all of you. It's, we are doing without replacement, due to which success probability for each trial is going to change. Is this fine? Is this all right to everyone? Yes, no? Are you getting this one, or is fine or not? Just simply say yes, no, or something, whatever you feel. You are okay getting, then we can move to the next part. Okay. So in binomial, actually, just keep in mind it's about independent trials. Okay, and for each trial, there will be only two possibility, either success and failure. And for each trial, success probability will be same. While in hypergeometric, for each trial, since we are doing without replacement, then for each trial, your success probability will not be same, because we are doing without replacement. So there is something, another question, which is called it's called Poisson distribution. Okay, Poisson distribution is again a case of discrete distribution. This is form of discrete. Binomial is also discrete, because we are interested in number, in count. Hypergeometric also discrete case, discrete distribution. Poisson is also. So when is the Poisson distribution occur? See, binomial we saw with replacement, number of for each trial there is success and failure, and for each trial success probability is same. For hypergeometric, success probability will get changed, because we are doing without replacement. When Poisson distribution can occur, so Poisson distribution, there is something happen, like suppose you are interested in to know the number of events occurring in a fixed interval of time or space. Okay. So I mean, what is this like meaning of number of events occurring in a fixed interval of time of space? I mean, this is something you can basically say, like okay, I will tell you. I will take the example so that it will give. Suppose normally we are denoting x follows Poisson distribution with parameter or lambda. Okay, so this is the one of the parameter. You can see in the binomial there was n and p. I mean, number of n is number of trials, p is the probability of success probability. Okay. So what is this x denote? Actually, x denote the number of times an event occur, or number of events occurring in a fixed interval of time or space, right? So let me take some examples, so that that will give you some sort of idea when to use Poisson distribution. So for example, let me suppose I'm saying uh, what is the meaning of, let's say, interval of time or space. I will write some example that will give you some idea. So I'm just writing events occurring in fixed interval of time. Okay. So what are those examples? Let's say I'm saying number of vehicles, okay, passing through traffic intersection in a fixed interval of time. In a fixed interval of time, you can simply mention, let's say, in first forenoon, I mean forenoon or afternoon or something like that, or fixed interval of, let's say, some 2 minutes, or let's say 1 minute. It means you are interested in to record the number of vehicles passing through an intersection in a fixed interval of 1 minute. Let's say 10 to 10:1, 10:5 to 10:6, something like that. You are interested to know the number of events occurring in a fixed interval of time. Let's say another is you can simply say number of telephone calls, received per minute at a call center. So you can say I'm talking about in the time space, right? Number of telephone calls received per minute, okay, at a call center. Well, and something, let's say number of people withdraw money from a bank or in a bank, from a ATM in a fixed interval of, let's say, 15 minutes. So here I'm talking about interval of time. What do you mean by interval of? Here you can say a number of events occurring, number of vehicles passing, number of telephones calls received, right? What is there any example for space? So let me write down. Let's say event occurring in fixed interval of space. Let's say events occurring in a fixed interval of space. So first example, I can say, let's say number of typos or incorrect spellings, right, in a book. So you can see I'm not talking about time. I'm not talking about in terms of time. I'm talking in terms of space. So book is a space, and I'm asking. I'm interested to know the number of events occurring in a space, like number of typos in a book, or let's say another. You can say number of defects per meter in a roll of cloth, right? So are you able to get this idea? Some sort of. So in such kind of scenario, Poisson distribution is helpful actually. Okay, so how we are denoting Poisson? X follows Poisson distribution with parameter called lambda. So what is the probability mass function? So probability x equal to x is nothing but e raised power minus lambda. This is a constant, mathematical constant, exponential. Lambda raised power x and divide by x factorial, because number of, let's say here, number of accident, right? Number of accident, you can find number of vehicle passing, something like that. So it can take value 0, 1, 2, and so on. It can take any value. So this is something probability mass function of your uh, Poisson distribution. And since we have seen the expectation of random expectation of binomial random variable, variance of binomial random variable, same here for Poisson. So expectation of Poisson distribution is nothing but lambda itself. Sometimes lambda will I mean they will not say this is a lambda directly. They will say expectation is given to you. Then what is the I mean, then you have to identify what is the lambda. You can simply take lambda, I mean lambda as expectation. Then variance of x is also lambda. So this is something uh, good property, or you can say good thing about Poisson distribution. So you can keep in your mind, e raised to minus lambda, lambda is for x divided by x factorial. So this is small x, this small x denotes the x number of events occurring in that interval of time or interval of space. Let's see this question that will help you. A car hire firm has two cars which it hires out day by day. The number of demands for a car on each day is distributed as Poisson distribution with mean 1.5. Here you can see it is given that mean is 1.5. That means expectation of x is 1.5. And we know expectation of x is what? This is the lambda in case of Poisson distribution. That means I have lambda. I can simply say x follows Poisson distribution with parameter 1.5. Yes or no? Are you getting how I took the value of lambda? Right? Because it will help you to calculate the value of this. Yes, okay. So it is asking calculate the proportion or probabilities of day on which neither car is used. Neither car is used means what? What should x what value x will take here? Tell me. Neither car is used means what? S should take value 0 or not? Right? If you see x follows Poisson distribution with parameter, then what is the PMF? Probability x equal to x. It will be e raised power minus lambda, lambda raised power x divided by x factorial. Here I'm saying x will take neither carriage, means x will take value 0. See here, x can take either 0, 1 and 2. So it will be e raised power minus lambda. What is the lambda? Minus 1.5. I mean lambda is 1.5. Lambda raised power x, 1.5 raised power 0 divided by 0 factorial. And we know 0 factorial is 1 and something power is also 0, 1. Something raised power 0 is also 1. It will be e raised power minus 1.5. So you can simply see if you calculate the value of e raised power minus 1.5 is 0.223. So this is something you can directly apply the uh, PMF of your Poisson distribution. Okay. So next question is based on called exponential distribution. Okay. So exponential distribution is nothing but comes for the okay. Let me write two things. Exponential distribution is, so far we have seen some distribution for discrete case, right? Exponential distribution is for defined for continuous random variable, because in this case we are I mean, see, exponential distribution is useful when we are interested in, length of something. I mean, see, in binomial we were interested in number of heads or number of success out of n trials. Yes or no? In Poisson we are interested number of events occurring in a fixed interval of time. Exponential distribution is helpful when we are interested in amount of time until, I mean, it's basically you can say distribution of amount of time, not number of something, right? We are interested in amount of time. So you can see until some specific event occur. Okay. So what do you mean? Let's say distribution of amount of time means I can simply say let's say length, life of light bulb. So life of light bulb is what? It's amount of time, right? So let's say I'm denoting x as a life of light bulb. So here, what is this light bulb last? Okay. So suppose what is this x can take any value greater than or equal to 0 or not, right? Here I'm interested in distribution of amount time. In this, in such kind of scenario, your exponential distribution is helpful because it's continuous case, right? If you see amount of time is the nothing but continuous, not discrete. So you can see a graph of exponential distribution like this. Some different value of x, you will get something, some values like this. Okay. So it's exponential. So in case of discrete, we have seen PMF called probability mass function. In case of continuous, it's called PDF. Okay. PDF means we are not interested in mass. We are interested, it's called probability distribution function. Probability distribution function. We are interested in distribution, actually not in mass. Okay. Actually, you can say probability density function actually. So density is what? Mass divided by, right? You can go from the physics, but we are not going to physics. So how we are denoting PDF? So PDF of exponential distribution nothing but lambda into e raised power minus lambda x. So x follows, this is the notation, x follows exponential with parameter lambda. Lambda is one of the parameter, it will be given to you. Okay, so here x can take any value greater or equal to 0, lambda should be greater than 0. And what is the CDF actually in case of continuous I mean in this exponential, CDF nothing but probability x less or equal to x is if you solve this, right? Okay, in case of continuous we cannot do summation. See, while in the discrete what we were doing for probability, suppose I'm asking probability x less or equal to 2, then what we were doing? We were adding, right? Yes or no? Are you getting this point? Anyone? In case of discrete, we were adding the probabilities, right? So in case of continuous, we can't add the probabilities. We have to integrate the probability. Integration is what is called continuous summation. So if you integrate, so what do you mean by this? You have to integrate till x, right? What is the lower limit of x? 0. If you integrate 0 to x, fx dx, that means 0 to x, right? Lambda raised power minus lambda x dx, right? Don't worry if you don't know the integration, that's not a problem. I'm just trying to explain something. If you solve this integration part, right? So CDF is coming out to be f of x is nothing but 1 minus e raised power minus lambda x in case of this exponential. This is the PDF and this is the CDF. This is cumulative distribution function. And expectation of your x will be 1 by lambda and variance of x is 1 by lambda square in case of exponential distribution. We are not going into the derivation part. Okay, this is something. And one more thing I would like to mention here. Then after that, I will go to that question. So if this is the case, probability A less than X less or equal to B, okay? If this is the case, then it will be same as probability X less or equal to B minus probability X less or equal to A. Why? Because suppose this is the A and this part is B. I'm saying X is here somewhat here. I wanted to know the probability that X is after A but till B. Then how will I get this? If I will subtract probability x less or equal to b, right? Minus if I will subtract this green, right, till a, then I will get this appropriate region or not? Yes or no? Are you getting? If you know, if you want to the middle part, you have to subtract whole red minus green, right? So this is something we have to keep in your mind. Actually, what is this? This probability x less or equal to b. What I can write? Can I write f of b? Because f of x is how we are defining probability x less or equal to x, right, minus f of a, right? And one more thing you can keep in your mind for continuous case, right, equality doesn't matter, means probability, I'm saying probability at a single point is always 0 because there is no jump. So if I will write probability a less than x less or equal to b, this is same as, then if I will write probability a less or equal to s less or equal to b, this will be again same, probability x less or equal to b minus probability x less or equal to a. Okay. Okay, how I have written like this? Okay, let me write one more thing. For this was the case, right? Okay. Here you can see, if I want to apply the equality sign, right? So for a less than, this was the case, then I have to add a probability, yes or no, to add a equality sign here. Are you getting? Since we are dealing with the continuous random variable, then probability at a single point will be 0. Because if you say probability at a single point means what? You have to integrate from a to a, fx dx, that pdf you will get this is the 0. Okay, so whatever this is the case, whether a is less than x less than b, you can simply write probability x less or equal to b minus probability x less or equal to a. Why I'm emphasizing on this? Because if you know the CDF, right, and you don't know the integration, suppose you know, you in your mind you know the CDF formula, you can directly apply this formula. Okay, so just you can go through this. Okay, let me come to this part. Okay, what I'm trying to say here, the lifetime of a light bulb is exponentially distributed. Here you can see lifetime of light bulb, right? I told you, right, distribution of amount of time is exponentially distributed with a mean life of 18 months. Okay, and it says if there is a 60% chance that light bulb will last at most t month, then what is the value of t? Is okay. First of all, x is question number 14. Let me write one more thing. So question number 14, x is lifetime of light bulb, right? This is given to us. Say x follows, we know x follows exponential distribution with parameter lambda. But in the question, lambda is not given. We have given the mean life of 18 months, right? And what is the mean of exponential distribution? It's 1 by lambda, I told you, right? You can see. But we have given 1 by lambda, right? We have given this expectation as 18 months. I mean, in the question, lambda is not given as 18. 1 by lambda is given to us. So what will the value of lambda here? 1 by 18? Yes or no? Are you getting? So see here, lambda is not given to us directly. Instead of lambda, we have given 1 by lambda because mean Sometimes it may be they can simply give the variance. So from the variance, because variance is 1 by lambda square, we can find the value of lambda here. So we got value of lambda is 18. Sorry, 1 by 18. Now next statement is there is a 60% chance that a light bulb will last at most t month. So what is the meaning of this case? I'm saying what is the meaning of it will last at most t month? What how should I write in the terms of mathematical expression? Yeah, tell me,
X
how should
should
I write in the terms of mathematical expression?
X should be less than or equal to 18.
Correct. X should be less or equal to t, right? Not 18, t,
T.
right? And this is saying this is the probability is 60%, right? That means 0.6. Yes or no? Now, in the question, we know, right? If x follows exponential, then what is the CDF part? Probability x less or equal to x. This is nothing but 1 minus e raised to power minus lambda x, right? Now this is same as something probability x is less or equal to small x. Instead of small x, we have t. Can I write this as a 1 minus e raised to power minus lambda times t or not? Tell me. See, I'm not going to do here integration. I'm just applying the formula of CDF. If you know the formula of CDF, you can solve the question. Right? If this is the case, can I write 1 minus 0.6? This is same as e raised to power minus lambda t. Correct? So this will be 0.4. This is same as 0.4 equal to e raised to power minus lambda t. Yes or no? We have to calculate the value of t here, right? So to find the value of t, we have to just simplify this equation. So can I write 1 by 0.4? This is same as no. Okay. Can I write this as e raised to power lambda t? Did you get it? Yes or no? Are you getting my point here? Why I'm writing like this?
Yes, sir.
Okay. No, not like this. Okay. One mistake. If you see,
Okay.
it will be 0.4 only, right? This is something I can write like this or not? Okay. If you see, if you take this e raised to power lambda t out, left hand side, it will be 1 upon 0.4, which is nothing but 2.5. So if you see, this is e raised to power lambda t, this is 2.5, will take a logarithmic, I mean natural log, then it will be ln e raised to power lambda t is equal to ln 2.5. So we know log e raised to power x with base e, this is nothing but x only, right? So instead of x, I have lambda t is nothing but ln 2.5. We have to find the value of t. T is what? 1 by lambda ln 2.5, right? So just mathematical simplification. What is the 1 by lambda? It's a 18, right? You can simply see in the question. 1 by lambda is 18. Is this clear? Okay, instead of this, suppose I ask x less or equal to t. Suppose I ask what is the probability that, for example, what is the probability that the life of light bulb will be between 10 months to 20 months, something like that. Okay. So if this is the case, I told you, right? I've told you if this is the case, I can write probability x less or equal to b minus probability x less or equal to a. Yes or no? Correct. So can I write this as a probability x less or equal to 20 minus probability x less or equal to 10? Then I can apply the CDF formula here. 1 minus e raised to power minus lambda x. Lambda is nothing but 1 by 18. So what is the lambda? Let's say lambda into 20 instead of x. This is the case. Minus 1 minus e raised to power minus lambda into 10. So whatever the value of lambda is here, you can simply put and you can solve the question. Okay. So you have to just keep in some simple formula in your mind. The rest it will be solvable. So we have some very last question. So for this, again, you have to keep in your mind something. Most probably, when you will go through the lectures video, right, that will help you a lot. Okay, I mean that you can relate more. So there is something called uniform distribution. It's called continuous uniform distribution. before few minutes, right? Few minutes before we have discussed discrete uniform. Now we will be discussing a continuous uniform distribution. So notation for this, we are writing as follows: uniform with parameter a comma b. Make sure it's a closed interval. So what is the form? Let's say this is x, this is the fx. So it's a uniform, right? Suppose this is the a, this is the b. Uniform is, suppose this is value taking the value k. So it will take same value, right? Same value throughout this part, this a to b. So that is the meaning of uniform. Okay. So one more thing I forgot to mention in case of exponential, this is the C. In case of discrete, uh, we were seeing all the probabilities should be greater or equal to 0 and summation of probability equal to 1, right? In case of continuous, here f of x will be 1 upon b minus a. You can solve this, right? If you solve this, you will get here x will lie a and b, between a and b. This is the PDF. So as we were doing in case of PMF, probability mass function, probability should be greater or equal to 0 and summation of all the probabilities equal to 1, right? Here what will the case? F of x should be greater or equal to 0 and integration area under the curve should be equal to 1. I mean, because in case of continuous, we can't do summation. We have to do integration. Okay, this is the PDF of exponential, uniform distribution. And what is the CDF? So CDF f of x is nothing but probability x is less or equal to x is nothing but small x minus a divided by b minus a. This is something you can keep in your mind. We are not going to the derivation part. For our simplicity, we can just keep in your mind. So this small x is nothing but this one, and this a and b is nothing but this a and b. Lower limit and upper limit will be given to you. So these are the basic formula which you can keep in your mind. And what is the expectation of x in case of uniform? This is nothing but a plus b by 2, and variance of uniform distribution nothing but b minus a whole square divided by 12. Okay, we are not going into the derivation part. We are just going with the formula itself. So you can keep in your mind this part. Okay. Okay, let me come to this question. I will try to explain so that it will give you the some sort of. Here you can see the traveling duration of time taken every day by a train is uniformly distributed between 200 and 220 minutes. So you can see here x is continuous. We are not counting. We are measuring the traveling duration. So what is the your x? X will be traveling duration of the time. It will follow simply. It will follow uniform between 220 minutes, right? So you can simply say this. You can simply this is A. This is the B. Right? These are two parameter. I will say question number 15. So I'm saying x follows uniform between 200 and 220 minutes. So this is my A, this is my B. So far so good. Now question is okay, before that, can you tell me what, if I will ask, what is the probability that duration of time taken is more than 215 minutes? If that is the case, tell me. What should I write only for more than 215 minutes? Or let's say, first of all, tell me less than 215 minutes. I will write x is less or equal to 215. If I'm interested only in this probability. Yes or no? I should write like this. Correct? Yes, no. Okay, well, suppose x is follows uniform a comma b. I told you, right? So what is the CDF? CDF is probability x less or equal to x. This is nothing but small x minus a divided by b minus a, right? So what is small x here? 215 minus what is the a? 200. What is the b? 220. What is the a? 200. So whatever the value of will be there, right? It's nothing but 15 by 20, 3 by 4. So this is the answer. Okay. This will be the answer for this scenario. But our question is, what is the probability that duration of the time taken is more than 215 minutes? It is asking probability that more than 215 minutes, given that on that day more than 210 minutes of the time was taken. This is the question, right? So in the question it is clearly mentioned we have to find probability x greater than 215 minutes, given that it is already took more than 210 minutes. Okay, now we have to solve very basic thing. We know what is the probability of a given b. It's nothing but probability of a intersection b divided by probability of b, right, in terms of event. So what is this intersection? Means common between a and b. So the same thing we have to do here. So what I will do here, I will write, suppose this is a and this is b. We have to write and part. So probability x greater than 215, comma means and, x greater than 210, divide by probability of this b, that means x greater than 210. Now just keep in mind, for the numerator part we have to find the and intersection part. So just draw a line graph. Suppose this is the 210, this is the 215. Okay, it says more than 210 already. Then we have to find the intersection between 250, more than 250. Tell me what is the common part between this green and red?
More than 215.
More than 215, right? This is the intersection part, right? So my numerator will be x is greater than 215 divided by probability x greater than 210, right? But one more thing you have to just keep in your mind. So I told you f of x, right? So a probability x less or equal to x is defined as how much? X minus a divided by b minus a, right? But if you simply see here, in the numerator denominator part, greater than sign is there, right? To apply this formula, what should I do? I have to convert this part in the less than equal to sign or not? Yes or no? So how can I convert? Can I write this part as a 1 minus probability x less or equal to 215? Because probability of a plus probability of a complement is what? 1. Suppose a is greater than 215, then a complement will be less than or equal to 215. Yes or no? Similarly, in the denominator part, can I write 1 minus probability x less or equal to 210 or not? Are you getting this?
Yeah.
Well,
Yeah.
and now I can apply the for this CDF formula, right? So I told you x is follows uniform 200 to 220, right? So what about this case? This is your A, this is your B. Tell me for the numerator part, what should I write? For this part, I can apply the CDF formula. X minus A, what is small x? Small x is this, right? So 215 minus A is what? 200 means lower limit, and what is the upper limit? Means B minus A, 220 minus 200. Are you getting how I am writing this one? Then numerator in the denominator is the 210. You can simply see small x is what? This part, right? So 210 minus a is 200 divided by 220 minus 200. Okay. So in the numerator I will get 15 by 20. The denominator I will get 1 minus 10 by 20. Let's solve this. It will be 5 by 20. Then 10 by 20. So 20 will get cancelled out. So 5 by 10, which is nothing but 0.5. So 0.5 you can see as this is the answer. So we have to actually be careful about this part. Sometimes we make the mistake to identify the intersection part. So what you can do, you can simply draw and you can find the that intersection, I mean common point. Okay. Is this all right? I think we have done with the questions, and almost we have covered all the topics. Okay. So I will share this PDF and recording as well with the ops team. They will share with you via mail. Okay. So I'm hoping you got the idea behind all idea, right? So far, this discrete and continuous and all. Okay. So is this? I mean, did you get some sort of idea?
Yes. Yes.
Okay. Yes. Yeah. Thanks. Okay. So thanks all. Any doubt? Anything? Any doubt? Any query?
We didn't
You,
receive the PDF or the recording which was
yeah,
sent.
I will share with the ops team. They will share with you. Okay,
Okay,
they will share with the via mail. Okay.
sure.
Okay. Yeah. Sure. Thanks. Then. Okay. There is nothing else. Then we can close. I'm assuming you got the some sort of idea about these distributions and expectation and variance and all. Yeah.
Yeah.
Okay. Then. Thanks all. Bye. Bye.
Okay.
Thank you.
Thank you.